Everybody see it now?
Mm-hmm.
Lesson 63. And this is our 63rd lesson on the biblical flood. We're getting near the end of the book, not too far away from the end of the book. We're in chapter 16. We've given evidence that the flood of Genesis 6 through 9 was brought about by God when he brought a planet, probably the planet Mercury, with ice rings close to the earth. And of course, we showed from several books, the book of Amos, for example, and other places, that there were rings around the planet. And the rings of most planets are ice and other particles. The planet approached the Earth above the ecliptic plane. We'll define that, what that is, in just a minute. When the Earth was near aphelion, we'll define that in just a moment. Here's aphelion. The Earth is at its furthest distance from the sun about July the 4th. It varies back and forth 2 or 3 days, but around approximately July the 4th. And about 6 months later, or roughly the 5th or 6th of January, anywhere from 4th to about the 8th, usually around the 5th or 6th, it'll be at perihelion. That's the closest it can be to the sun. So the Earth's orbit around the sun is not circular. It's sometimes further away than at other times. And so that's called aphelion. It's from helios, which is the word for sun, and apo, Greek words. And this is peri, Greek preposition, helion for sun, right? Now, right here, the flood began right after aphelion. And we had evidence of this based upon several factors. And so we began probably around the middle of what we know as the month of July, probably the 8th or 10th or maybe the 15th of July it began. And the flood ended about 150 days later. The planet Mercury made 3 passes, actually probably 3.5 passes when you count them all, around the Earth. And it took 50 days for each pass to go around the Earth. And so it was 3 passes in 150 days. The fountains of the deep were breaking up for 150 days. The windows of heaven were 150 days, but the rain only lasted 40 days. So the flood ended after 150 days. Now, if the planet approached the Earth near aphelion, the Earth would have its most influence upon the planet as far as holding it as a satellite circling around it. At a distance of about 1 million miles from the Earth, the sun's gravity and the Earth's gravity are equal. So if the planet Mercury was able to circle but not get to 1 million miles, it would stay in orbit. But if once the Earth got close enough to the sun could pull it away. And about this point, it pulled it away. I believe that the planet Venus actually helped the sun to pull it away, and we'll have evidence of that. So it pulls it away from the Earth. Now we'll come back to this some more. Let's explain perihelion and aphelion. In January, perihelion occurs. The Earth's tilted on its axis about 23 degrees, 23.5 or something like that degrees. And so in January, what we get is the Earth is closer to the sun about the middle of the first week of January, 7th, 8th of January, 6th of January, somewhere thereabouts. It's closest it can be to the sun. And then 6 months later, around the 4th of July, it's the furthest it can be. Now, the reason we're hot in the northern hemisphere at the 4th of July is because the Earth is tilted on its axis. We're getting more hours of sunlight. We are further away from the Earth, however. We're further away from the sun in July than we are in January. Now, I'm going to digress just a minute. I believe it's in the providence of God that occurs. because the southern hemisphere, which is tilted in January toward the sun, is mostly water. And water warms up and cools off at a slower rate. And so the fact that it's closer to the sun in the summertime, when it's going to get this direct sunlight, when it's tilted so it gets direct sunlight, it'll tend to warm that water up that's in the southern hemisphere. Water takes a longer time to warm up than land does. I want to illustrate this in the United States. The states of Iowa and Nebraska are roughly the same latitude, that says how far they are from the North Pole and from the equator, as the state of Ohio. But the states of Iowa and Nebraska, and let's don't factor in the elevation because that's a little bit of difference. But what we get is the states of Iowa and Nebraska have their fall beginning sooner than they have in Ohio. But their spring begins sooner because the there's no water north of Nebraska, no big lakes north of Nebraska and Iowa. And so there's no water there to warm up and cool off at a slower rate. It takes a lot of energy to warm a gallon of water up. You take a cubic foot of water and a cubic foot of salt, and the water takes a lot more energy to warm it up. And so what happens is in January, the southern hemisphere's got this direct light and it's closest to the earth. So it's closer to the earth here in the southern hemisphere, and that warms it up quicker. And so it's able to warm that water up. Whereas we have the direct light in January to warm us up in the winter. So this makes our winters milder and our summers milder in the northern hemisphere. The same thing happens in the southern hemisphere because of so much water there. God, I believe, is at work. But that's a side point that's not part of my flood materials. Any questions or comments there? All right. Okay, that's your distance. The ecliptic plane, I have this, I made this up today. If we draw a line from the center of the earth, a straight line through the center of the earth and the center of the sun, that's called the ecliptic plane. And so that's a line through there. And I'm saying that the planet Mercury was in an orbit that went way out, come around the earth, and it come in above the ecliptic plane. It was above it. And it just, at this time, it come close to the earth. So it's above the ecliptic plane and coming out. Now, here's another, the following slide is of 4 planets lined up along the ecliptic plane. This is a picture taken near the equator of the Earth. It's taken in July of the year 2010, and showing the planet's orbit of the sun in nearly the same plane. Of course, it's taken from right near the equator, from Java in Indonesia. So here are your planets, Saturn, Mars, Venus, and Mercury, lined up, pretty much lined up. So they're all lined up in the ecliptic plane. Here's another arrangement of it. Here's your planet, there's Saturn, and here are your other planets that we have here lined up. They're all lined up in the same plane, pretty much. Here's the Earth with the moon around it. There's Mars, there's Venus, there's Mercury, there's the sun. Here's the asteroid belt, and here's a comet coming in. There's the Jovian planets, the 4 Jovian planets, Jupiter, Saturn, Uranus, and Neptune. And here's the planet that's no longer a planet, that's Pluto. Okay, so right here is your the belt of the asteroids, asteroid belt. Now, when we look further into this, that's what we mean by the ecliptic plane. Now, what I'm saying is this planet, and I believe it had ice rings, Amos tells us it is called Orion, which is in Hebrew, is a star that's fat in the middle and it has rings. Orion has bands or rings according to the scriptures. And so it had rings or bands around it, and that would be probably ice rings, mostly ice particles. So these rings then would go around it. Now, when it went around the Earth would pull the rings toward it as it went around the Earth, coming toward the sun. The first pass, it went down, and as the sun was tugging upon it, it would pull it upward. So the next pass, it went around the Earth and come up like this. And then the third pass, it come up and went around like this, and almost back in the ecliptic plane. And so it would be pretty much in the ecliptic plane. I believe Venus was right over in here about this time and pulled it toward it. So Venus is up here in the ecliptic plane, pulling it toward it as well. It's up in an orbit around us, around the sun. So it made 3 passes. So its rings then get pulled toward the Earth. Right? Planet caused tidal actions, which upset the isostasy of the Earth. Now, if you've ever gotten in a boat, if you stand up, if you are on the dock and you stand in the boat sinks down in the water because your weight makes it sink down. That's isostasy. That is, it will go to the level of the support. I don't want to go into it any deeper, but the more weight you put in, the deeper the boat sinks into the water. If you get too much weight, the boat will sink. So it's based on some physics, laws of physics, basic physics. And the magnetic and gravitational fields, the isostasy of the Earth was upset. And so when water goes over the continents sink into the magma. Of course, when that happens, then it's going to put forces other places on the Earth. They're going to get volcanoes occurring. The magnetic and gravity fields of the planet and the Earth interacted and shifted both the planet and the Earth upon their axis. The ice rings were attracted toward the Earth by the Earth's greater gravitational field. Now, ice is a particle that can be deflected by a magnetic field. There's 3 kinds of magnetic materials: ferromagnetic, paramagnetic, and diamagnetic. Diamagnetic materials will be moved, or they'll tend to try to go parallel with the magnetic field. Ice particles are diamagnetic, so they'll come in at the polar regions. This is why we have ice at the North and the South Pole, because the ice would move parallel to these magnetic flux lines. And that's what happened. So what I'm claiming happened here. So the ice, now this is showing it in the ecliptic plane, and the ice is going both places, North and South Pole. But it would be tilted on one side, it would go to one pole, and then as it moved around above it, it would go to this pole up here, the North Pole. And so when it swung around like this, the ice would tend to go to the South Pole. So the ice would go to both poles as it come off the ice rings. And of course, it will begin to deplete the ice rings. Now then, this ring would be pulled, the ring that's away from the planet will be pulled toward the planet. The planet Mercury has lost all of its crust. They say it has no crust. And so the crust is pretty well all gone. I think the crust of it was lost and went out into space out in here around it. Some of it hit the Earth. Some of it hit the moon. Some of it hit other places. This probably increased the eccentricity of the orbits. Now, I'm going to have to define what eccentricity is. If you've had a course in analytic geometry, you know what that is. If you take a circle, we'll see what a circle looks like, it's eccentricity-wise. And you take an egg-shaped object, it has the change in eccentricity. The increase in eccentricity caused parts of the rings to impact Mercury, and even some of them to hit the moon. The ice rings were deposited symmetrically about the magnetic poles of the Earth. Both meteorites and large chunks of ice cause impact craters and what we call antipodes on the opposite side of the Earth. So we're going to see those in just a moment. If the impact were perpendicular to the Earth, the antipode would be on the opposite side of the Earth. Now, let's see what an antipode is in just a minute. If the impact was at an angle, the antipode would be found by some vector forces. We have to get into some more complicated mathematics. Now, here's a website that will link you up with antipodes, and you can type this in and do a search on it and see more information about it. Here is an early antipode diagram. We have a circle here, a circular object with a core inside it, and the impact comes in perpendicular to it. The forces will go through it at different speeds due to the difference in the density of the material. And these forces then, these pressure forces, will go off the side and bounce back. And what will happen is, if it's symmetrical, everything's symmetrical, these forces will wind up down exactly the opposite side of the object. Now, this being the planet, when an object impacts the Earth, for example, or the Moon, or Mars, or Venus, or some other planet, then it causes impact craters where it hits, and then it bulges on the other side where it comes out. That's called an antipode. So instead of coming in, it pushes it out over here. Now, of course, the Earth is not entirely round. We'll see this in just a moment. But these are simulations of it, and that's what happens. It's perfectly good physics. Here's another diagram, and both these diagrams come from this source that I gave you right here. You can find them at that source. I'm not going to spend more time with them. The early antipode models were based on the assumed spherical shape of the Earth. Go back and look at it. They have the Earth being round or sphere. But the problem with it is the Earth is not spherical. It's not round. Because it spins, it bulges at the equator. So it bulges out at the equator. So it's oblate. And so their model mathematically was incorrect. So they would not get the antipodes in the right place, or they wouldn't have the right forces, because the predicted locations and the forces of the antipodes that they expected to see were not right, because they had the wrong mathematical model. Now, a new, more accurate model that was based on the fact that the Earth is oblate, which means it bulges at the equator because it's spinning, more accurately predicts the locations of the antipodes. And this was developed, and also not only the locations, but the amplitudes of them, the height of them, was developed at Princeton University. Here's a link that shows you that site. And of course, you can, this is on the internet, you can pause it, type that site in, and get the link to it. Early models were based on a spherical planet. They didn't take into account the actual shape of the Earth. It's oblate. This model takes into account the actual shape of the Earth, and it's more accurate. The math is more complex, of course. Antipodes have been found on both the Earth, the Moon, Mercury, Mars, and some of the moons of the Jovian planets. Now, your Jovian planets are all planets that are like Jupiter. Now, Jove is, I believe, the Latin name for Jupiter. And that would be the god Jupiter, the false god, of course. So your Jovian planets would be Jupiter, Saturn, Uranus, and Neptune. Those would be your 4 Jovian planets. Here's an impact basin on Mars. The impact occurred where the red dot is. The other side of Mars, right here is the red dot, the other side, the impact. And then there's through the center of Mars, we come through. There's the antipode on the other side of it. It bulges out. And so we have a bunch of magma. This was a huge volcano occurred over here, where this on the other side of where it got impacted. So it was impacted with a big crater, and then the other side has an antipode where it bulges out. That's exactly what we'd expect from forces. And it comes out the center of Alba, the largest volcano on Mars. It's 1,600 kilometers across. Kilometers about 0.6 of a mile. And although it's fairly flat, it produced a great amounts of lava. Doesn't bulge up too much, but it's got a lot of lava that flowed out of it. the bottom of the moon has one. Now, this, of course, could occur if a planet come in above the ecliptic plane and comes in above it. If it happened to be above the moon, it would have craters on the top of the moon, and when it got to the other side of the moon, the Earth, if the moon was below it, it would have impact craters on the south pole of the moon. So this is from the Nature magazine. It's published in England, volume 453, pages 1160 to 1163. And so that's the south pole of the moon, which is cratered. Incidentally, it has ice in the craters at the south pole of the moon. And that's what we expect from the ice rings. Here's what we call seamounts. This is under the ocean. There are these places where it's been elevated up. Some of them are elevated so far that they have become islands. So they're islands that have come up. And so they're just seamounts, they're called. Now then, the atheist claims that the Earth, all the land was at one time was in one place. Now there's a passage in Genesis that some have used to say this, and they may be right. I wouldn't rule out this possibility. I'm not saying this is what happened, but this is what the atheists claim. It was called it Pangea. Pan is all, and Gaia is land. So all the land was in one place. That's their claim. And then it spread out. I would think that the flood, a flood caused by a planetary action, could pull apart the land masses. It possibly could do that. And of course, some have used Genesis 1:9, and God said, "Let the waters under the heaven be gathered together under one place, that the dry land appeared." It was so. The assumption is made the dry land was all in one place. That may be what he's saying. I don't read it that way, but it might be. If it is, it still wouldn't necessarily rule out my model, because the forces could have slid the land masses over the top of the Earth. The fact that the waters are gathered together in one place doesn't necessarily mean, however, that the land was all in one place. Right? I don't think that's true. Here's their model of it. And one of the impacts here, we have the Chicxulub crater, which is Yucatan Peninsula right over here. The opposite side of the Earth in their model, we have an antipode down here in the ocean, just the opposite side of the Earth. So there's a seamount down here where it bulged. So this crater here caused it to bulge on the opposite side of the Earth. We have also the Deccan Trap, and this is what is now India, and it has Deccan Trap's antipode over here. And this is just west of what we call the country of Mexico here, out in the Pacific Ocean. So we see these antipodes, they're there, and we know if we find an antipode, we look on the other side, there's a crater on the opposite side of the Earth. So this probably greatly increased. Now remember, our craters that we find earlier, we find a crater and then we have it filled with sediment, and then there'll be another crater and sediment above it. And of course, if we believe the sediment was all laid by the flood, we have to have these craters being formed during the flood, because the craters are filled with sediment, and then there's more craters above it. So, of course, my model will allow this to occur, and it actually predicts that it should occur. This probably greatly increased the eccentricity of the orbits of the ice rings, and increased eccentricity caused parts of the rings to impact the planet Mercury and the moon. In addition, the ice rings were deposited symmetrically about the magnetic poles of the Earth. Now, we'll come back to this. Here's the sun and particles coming from the sun. There are nuclei of atoms coming from the sun and electrons coming from the sun. What we have is these particles coming from the sun. When they come to the magnetic field of the Earth, they're deflected. And of course, the Earth is tilted on its axis. I don't have it tilted in this diagram, but it is tilted. So in the summertime, the particles wind up coming into the north polar regions, And that's what we call the Northern Lights. You can see it. I've seen the Northern Lights, but I haven't been up to Alaska, but I've seen them here in Oklahoma. At one time, we could actually see them. There was a time we could see them. So I drove my family about 70 miles north of Oklahoma City to get away from the city lights so we could see them. We saw them. But you go further north and you can really see them. And then the Aurora Borealis, that's Northern Lights. And then in the summertime, that's the Northern Lights. In the wintertime, there'll be lights in the southern hemisphere. Aurora Australis is southern, so that's Southern Lights. Aurora Australis, Aurora's lights. What happens is that we got the tilt on the Earth's axis. So these particles, ions and electrons, come in at the North Pole, around the pole. Now, we remember we've already shown that the magnetic pole is not at the North Geographic Pole. They're not in the same location. And atheists have a problem with that, but my flood model doesn't have a problem with it, because it might be expected by my model, in fact. So they'll come in near the magnetic poles, not the geographic poles. So because of the location of the magnetic pole, you don't have very much of these in the northern Russia, but you do in Canada and Alaska and the northern United States. Now, the rings, the ice rings, are diamagnetic, and so they will go parallel to these flux lines. The small ice particles will then come in at or around the magnetic pole, both the north and the south pole. And so this is why we would have ice deposited in the north and the southern and the south poles more than other places, because it would follow the magnetic flux lines. Now, I have it going both ways, but it will be tilted, and it would come down like this, and it would be going down at the bottom when it's here. When it's up here, maybe up here, it would come in the top. So the first pass, it got the most, and that went to the North Pole, northern region. We haven't got to the eccentricity yet. I have a slide that'll show what it is, but it's an egg shape rather than round. That's what eccentricity is. And it increased the eccentricity of the orbits of the ice rings and made them more egg-shaped rather than round, increase the rings in this. So these ice particles in the rings began to hit the planet Mercury. When they were on the opposite side from the Earth's gravity pulled them toward the planet. Same thing would happen if the moon is involved. Some of them could impact the moon as well. The ice rings are deposited symmetrically about the magnetic poles of the Earth. We've already seen that, evidence of that. Here's what eccentricity is. An eccentricity of 0 is a perfect circle. As the circle gets more oblong, egg-shaped, eccentricity of 0.5 is here. There's a mathematical formula for it, 0.9, 0.75. So 0.9 is really a real egg shape. This is elliptical. And so there's a definition for it. But see, that's called an ellipse. Well, this is an ellipse here too, but they have what they call major axis and minor axis and so forth. And so we have here the different shapes. And I just call it egg-shaped. That's the quickest way I can describe it. But there's a mathematical formula for it. But when you get it shaped like this 0.9 eccentricity, and this is Mercury, and maybe the Earth is over here pulling these over toward the Earth, up over this location. They're being pulled toward the Earth. They'll be pulled into Mercury because Earth's got a much bigger gravity. Particularly, it would happen so if the sun happened to be over here helping the Earth do it, and it happened to be in that location. Here's the model for eccentricity, and you can actually click on this site. I'm not going to do it. I won't mess me up and lose my link. But this will go in and show you a mathematical model that actually shows eccentricity. As the planet approached above the ecliptic plane, the Earth, the ice from the rings, was first deposited on the North American continent. Then parts of the rings were deposited on the Eurasian landmass, that would be Europe and Asia. This asymmetrical, it's not symmetrical deposition of the ice, upset the isostasy of the Earth. It's like if you stepped into a boat, you have a small boat, and you step in the back end of the boat. What's going to happen? The front end will tilt upward. So you need to step kind of in the middle to keep it kind of balanced. Well, what happens when you deposit large amounts of ice on one side of the Earth, it begins to wobble like a tire out of balance. And so that would cause the Earth to move around. And the ice on the continents would make them sink. The continents are all floating in molten rock. And you put extra weight on them, they'll sink deeper into it. Now that molten rock has to go somewhere from Pascal's law. It would create forces throughout all the Earth and push the crust up in other places. So the Earth's crust then would break apart and be cracks in the crust. This is where we'd start getting volcanoes and earthquakes would occur. And of course, the planet itself would pull on these crusts that are broken apart now in different angles. So the crust would move in different directions. This would make the crust move against the crust, creating fault zones as we see today. So the fracturing of the crust would occur at this time. So here it is coming in, it comes in above, comes down. Go back again, it comes in above, comes down. Then the next pass, it comes over and comes up here a little bit. The sun is pulling on it. And the third pass is pretty much almost in the ecliptic plane. And again, as I said earlier, Mercury's over here helping to pull it. And we have evidence that Mercury, this is not drawn to scale, keep that in mind. The asymmetrical deposition of the ice, more of it on the northern hemisphere at first, upset the angular momentum of the Earth. It began to wobble like a wheel wobbling in a tire. And that can happen if something happens. Like on an airplane, if one of the blades on the propeller got broken off, the propeller would then make the plane wobble and cause tremendous stress on the plane, on the engine itself. Upset the angular momentum of the Earth, caused the crust of the Earth to move on the mantle to adjust for the change in angular momentum. So now we have the crust of the Earth moving around and the continents probably moving. This was fantastic amounts of stress. Bad stuff is going on right here, real bad stuff. Noah and this ark is being protected by God and all the animals that are with him. God's taking care of him. So that ark is floating around on the water and it's safe. And this would be similar to an automobile wheel that went out of balance, started bouncing around on you. If you've ever had a wheel out of balance, you know what I'm talking about. The faster you go, the more it'll bounce around on you. This is one of the mechanisms that produce both rifts and mountains in the crust of the Earth. So this helps to produce mountains as well. One of the things we see. The tidal friction, the tide of the Earth and the tides, remember there's three kinds of tides. There's water tides where the water goes up and down. There's also land tides called solid tides where the actual crust of the Earth goes up and down. And even the moon causes tides in the Earth where it goes up like a couple of feet every day. Probably Oklahoma City, where I'm sitting right now, goes up and down about a foot and a half, 2 foot every day. But everything around us goes up, and so we don't notice it. But they can measure it with their satellites, and it's actually going up and down every day as the sun moves around the moon. And so this occurred. It slowed the rotational speed of the Earth and changed the oblateness of the Earth. So the Earth bulges at the equator because it's spinning, so it slowed it down. So the spinning motion, somehow it has to lower its diameter. And so the Earth doesn't bulge, and so that bulge has to rise up somewhere. So here's an oblate sphere, a spheroid. It's fatter across this way than it is up and down. And that's what we see here. The Earth swells at the equator because it's spinning. The change in oblateness caused a decrease in the equatorial radius and caused some of the crust of the Earth to be elevated, raising mountains such as the Andean Mountains in South America, even the Rocky Mountains in North America. Probably were elevated to some extent by this means, along with the elevation due to the gravity of Mercury. Gravitational field of Mercury was probably involved in elevating mountain ranges. The atheist has no mechanism to raise the mountain ranges. There's no forces that he can come up with that would raise the mountain ranges up as high as they are above the ground. They should sink back in, according to his model, but they don't. They're there. Other mountains, of course, were elevated due to volcanic activity. We know some mountains are volcanic in origin. Of course, there was a lot of volcanic activity going on as the crust breaks apart and magma begins to come out. The volcanic activity in conjunction with the ice coming to the windows of heaven caused the water vapor canopy to rain, dust up in the atmosphere, plus the cold ice caused the water to come out of the atmosphere. So that was your 40 days of rain, where that depletes the bulk of the atmosphere, the water vapor in the atmosphere. And that then man loses his added barometric pressure and the protection of that water vapor canopy from mutations. The loss of the canopy, along with the loss of fertility of the soil. Now the soil, instead of having the right mixture of minerals, because of the moving water separates the minerals out by their density. And so we have layers where there's copper in one place, gold in another. And so all of these things like silver and gold were distributed throughout the soil originally. And we need a little bit of gold, a little bit of silver, a little bit of copper in our food to make it nice and healthy. Not too much, but a little bit. Australia has almost no copper, so they have a deficiency in copper in their plants. And that makes their plants not as healthy. So it caused the post-diluvian conditions to be different than the antediluvian. Post-diluvian is after the flood. Antediluvian here is before the flood. Anti is Latin for before. And so a lot of your plants and animals became extinct or unable to survive in the post-diluvian environment. So they died out. And the plants no longer have the fertility, the fertile soil that they once had. So they don't have the vitamins in the plants that they needed for the animals that eat the plants to be healthy. And they reduce the longevity of all living organisms, including man. And that's exactly what we see. Noah's son Shem only lived 600 years, but Noah lived 950. So there's quite a difference, 350 years difference in the age of those men. And I would assume that probably Ham and Japheth probably lived about 600 years also. I'm assuming they lived about the same time as Shem. But the longevity of man went down after the flood, exactly what we'd expect from the things that we see occurring from this. These conditions reduce the size of many plants and animals. If you have reptiles, like lizards, they grow all their lives. And if these reptiles were able to live 500-600 years, what we call little horned toad in the United States, I've seen one maybe 6 or 7 inches long. That's about as big as I've ever seen one. Then they could get to be 30 or 40 foot long if they live to be 500, 600, 700 years, because they just keep growing all their lives. Most mammals, when they reach maturity, they quit growing, but reptiles don't. So that's where we could get big dinosaurs, and we probably have variations of those dinosaurs today. They just don't live as long, don't get as large. Komodo Dragon gets up to be about 10 or 12 foot long, and a young Komodo Dragon is like a lizard that climbs up the trees. But when it gets bigger, it gets down on the ground and walks around. Look almost like two different animals, but at different stages of development. That one of them lived to be 500 years old. He might be 30 or 40 feet long, 50 feet long. So that will get quite large. The planet probably escaped the domination of the Earth's gravity by two forces: the slingshot effect that NASA uses to pull their probes around, their probes that they send out into space. They will actually shoot a probe toward Venus and let it go around Venus, and then Venus speeds it up and it goes back around the Earth again, comes back around Venus, gets sped up some more, then it will slingshots it back out into space. They may go let it around another planet or two and let it speed it up. So the gravity of the sun, aided by the gravity of Venus, the planet Mercury was pulled away from the Earth's orbit. And when it got past and closer than further than 1 million miles away from the Earth, the sun pulled it away. Because at about 1 million miles, the Earth and the sun's gravity are equal. You get Venus in, and get Mercury further than 1 million miles away from the Earth, and the sun will capture it, and it'll be pulled away from the Earth. And then what happens is, if you've ever watched an ice skater, they'll start spinning, and they will move their arms outward and they'll slow down in their spin. They move them inward, they'll speed up. And this is all due to the rotational speed. There's what's called angular momentum. When they move them in closer, they conserve angular momentum. They had got to go faster. But if they move their arms out, they'll slow down. And of course, ice skaters are certainly ways. It's beautiful to watch them do it. I think it's wonderful. I love watching them do it. But it's all based simple physics. And so the Earth, once it had Mercury to pull away from it, it would change the speed, the rotational speed of the Earth. So the Earth's rotational speed then would slow down. And we see evidence of that. We'll see that in the next lesson or two. It's called the transfer of angular momentum. It increased the speed of Mercury and slowed the Earth down. As it passed around Venus, it caused Venus to rotate in the opposite direction. Because the rotational speed of Venus, as it went around Venus, it went around in such a way that it slowed Venus down, made Venus rotate backwards. So it come from the Earth, it come around Venus, and caused Venus to rotate this way, but Venus was rotating this way. So it slowed Venus down, and Venus rotates backwards to the way we expect it to rotate. And this would explain it. Now, what this would do is the rotational energy of Venus then slowed Mercury down, put it in an inner orbit. And that's exactly what NASA does with slingshot effects. When they wanted to take a probe and make it go to Mercury, they had to slow it down, and they'd run it by a planet like Venus to make it slow down. So it could go into orbit around Mercury. It's going too fast. Otherwise, the sun would pull it in and speed it up for us. So NASA actually used this principle to get a probe to Mercury. They've sent some probes to Mercury. At or near the end of the flood, fragments of the planetary rings return to the Earth. Now remember, the rotation around will be about 50 days to rotate around the Earth, the planet. So after 150 days, the third rotation, it was lost. Another 50 days later, it would come back to the Earth. The rings of it would, the fragments. If we go back now, I'm going to go back here. Once it leaves, it's got rings around it. If it rings here, any of the rings that are closer than 1 million miles to the Earth will be pulled back to the Earth. Those rings then would rain down upon the Earth. Meteorites. Coming down the meteorites, there'll be molten rock and there'll be hot rock. And they'll probably would strike the Earth and cause craters. And also, they would have iridium in them and other platinum group metals and give us what we saw the last two lessons on the fires that no doubt occurred. At least one object caused a tsunami wave that left alternate layers of mudstone and sandstone in Texas. This is on the very surface of the Earth. So this probably come down after the flood ended. Here's a source for it in the book. They caused the wood and other organic matter left by the flood to burn, which affected the climate, as we've already seen in our last two lessons. That's the summary of it. Hope it's been helpful to you. We'll follow this up with another lesson. Do you have any questions?